I still want to graph a quadratic function. In this case, y equals negative 3x squared, where a is negative 3. We haven't taken a look yet at what happens if the a value is negative. But what we always do is compare it to y equals x squared and then all of the following. So I'm going to make a table first, kind of like we've done every other time. Here's my table, x and y. I'm going to choose all of the exact same values of x from negative 3 to positive 3. So if I input negative 3, you have to square x first. Exponents always come first. That's 9. And then times negative 3. 9 times negative 3 is negative 27. Negative 2 squared is positive 4. 4 squared times negative 3 is negative 12. Negative 1 squared is 1. And then times negative 3 is negative 3. 0 squared is 0. Times negative 3 is 0. 1 squared is 1. Times negative 3 is negative 3. 2 squared is 4, times negative 3 is negative 12. And then lastly, 3 squared is 9. And then times negative 3 is negative 27. And I'm going to graph those points on my graph. So notice what I did on my y-axis. On my x-axis, I'm going by ones to be able to fit all the points. If I went by ones on the y-axis, I wouldn't be able to fit all of these points. So I'm going by 3s on the y-axis, and I labeled everything. So you should kind of pick a correct value you can go by on each of your axes to make sure all of your points fit. But I have negative 3, negative 27, here's negative 3. And then since I'm going by 3s on the y-axis, here's negative 27, negative 2, and then negative 12 would be right here. Negative 1, negative 3, 0, 0, 1, negative 3, 2, negative 12, and then lastly, 3, negative 27. Still a parabola. The graph of every quadratic function is a parabola, so it's curved. I should have arrows at each end, but I'm going to label it, even though I'm going to color coordinate things here as y equals negative 3x squared. What we wanted to compare that to is y equals x squared. I'm not going to remake my table for that, but I have 0, 0, negative 1, 1 would actually be right here. 1, 1 would be here. And then it's 2, 4, which would be right about here. Negative 2, 4, and then, excuse me, negative 3, 9, and then positive 3, positive 9. So here's a graph of y is equal to x squared. And I want to compare those. One, if I'm comparing those, this graph is flipped or it's reflected. Specifically, the line of reflection is the x-axis. So we say it's reflected in the x-axis. I think you went over transformations last year. One of the different transformations is a reflection. Okay, another thing that happens is there's a vertical stretch, just like with our other examples that we went over. Going back to it's reflected. It's reflected because a is a negative value. A is negative 3. And it's a vertical stretch specifically by a factor of, in this case, just 3, not negative 3. The negative makes the graph flip or is reflected. Okay. And then we could figure out the vertex. The vertex is still right here. The vertex is 0, 0. The graph opens down for y equals negative 3x squared. This graph, it's, instead of a U shape, it's an upside down U. You think about it as like a hill or an umbrella, but the graph opens down now instead of up. And then lastly, the axis of symmetry. So the axis of symmetry still goes right down the middle. Still, in this case, the y-axis, the axis of symmetry for both these graphs is the same. So the axis of symmetry should be the equation x is equal to 0. So those are all the characteristics of the graph of y equals negative 3x squared.